We're looking at the first FRQ problem, and we are going to go ahead and we are going to answer this as a team. Know that number 1 and number 2 for your FRQs are going to follow the same format. So number 1 is going to be a function problem, and that's what this video is. Every FRQ you have for number 1 for precalculus will be based on a function type problem. It may be a different function, but it's going to be similar in the questions. And know that you'll always get to use a calculator. Let's get started. How do we answer this? So if you are with me in class, or if you're rewatching this, you're going to take a look at the sample booklet. You're going to turn right now, and you're going to find part 1A, and you're going to write this down as I go through it with you. Let's get started. Now, here's one thing you need to know. They want you, whenever you have to round, unless they tell you specifically otherwise, round to the nearest thousands. So on your paper, write that down. Round to the nearest thousands. Write that down somewhere. Unless they tell you differently, round to the nearest thousands. The next thing I need you to know is never circle your answers. I am so accustomed to saying, hey guys, circle your answers. It makes it easier for me to grade. If you circle your answer, it will only look at what is circled and it will ignore everything else. So if all your supporting documents lead up to like x equals 2 and you need to show evidence, but you circle x equals 2, the graders are only allowed to grade what is circled, and then you would not receive credit. So do not ever circle your answers. Everybody good with that? Okay, here we go. Also, a difference, by the way, between precalculus and calculus is calculus is told to say, give me all the information you know, give me everything you know. Precalculus really wants you to try to shorten it and be precise with your answer. All right, we're going to get started right now. Looks like we have a composite function here. The function h is defined by the following. Write the value for h of x as a decimal approximation, or indicate if it's not defined. So I'm going to grab my paper. Okay, I've got it right here. You're doing the same with me right now, and I'm going to write down everything that I would put down. So let me grab a pen in which you can see. This is what I would write down. I would write down, okay, I know h of x equals, and I'm going to put it in this composite function form. Okay, got it. Now it wants me to figure out it wants me to know what is h of 4. Like that's what we want to find out, correct? So what I'm going to do is I'm going to drop down, this is just so you understand, I know that I'm going to start with x equals 4. My input value is 4. So I'm going to come back over here. I want to ultimately know what is the output value when my input value is 4. Now to figure out what the output value for h of x is, I got to do the work on the right hand side. And if you've forgotten how composite functions work, notice that wherever there was an x, an input value, I dropped in a 4. Okay, so if you've forgotten how composite functions work, you always start on the inside here. So I'm starting on the inside, and I may even come off to the side here and kind of show my work. Okay, so what is the output value when x is 4? So I come up over here, I realize that this is the function f, and I find where is x equal to 4. Well, when x equals 4, we can see the output value is 2. Okay, got it. So then I come back here and I can replace f of 4. I know that output value is 2. All right, but we don't have up here, we don't have a function for g of x, but if I go back to this original function, I can see here's the function g of x. Now I want to show all of my work. I want to make sure that whoever is grading this absolutely gets that I understand what is happening. So I'm actually going to do all of this work off to the side, and then I'm grabbing my calculator because I know this is a calculator related problem, and I'm plugging it in as so. And remember, it is easy. Oh, see how I made a mistake? I'm rushing through this. Do you see how everything is actually up here in the excellent position? So good thing I caught that. I'm going to start again here. And I want to make sure I plugged it in correctly. That all looks great. Okay, so here's what I have. I have g of 2 is equal to negative 9.3. So here we go, negative 9.3. I am not circling anything. I am not circling anything. I believe that whoever is the AP grader can see the progression of my thoughts. Okay, we start with this, And then on the right-hand side, I can see that I'm going to substitute in x equals 4. I can see that I went off to the side. Okay, when f of 4 is equal to 2. Okay, good. So I plug in the 2. I can see all of my thoughts here, and I can see this is my final answer. This is my final answer. Let's go to the next part. We're going to go down to part 2 before I had you correct your work. Find all of the values of x for which f of 3, and then indicate if there's no such values. Okay. Okay. F of x equals 3. That means, what does this mean? It means I want to know at what input values, if they exist, will the output values equal 3. So what I'm going to do is I'm going to come up here. This is the function f, and I'm looking for when are the output values 3. Oh, they're 3 at 5, and they're 3 at 7. They're 3 at 5. Excuse me. And they're 3 at 7. So a couple different ways we could do this. F of x equals 3 when x equals 5 and when x equals 7 for the function f. Also, I would prefer you to write it like this. I think it's just a little more clear cut, but I believe this is right. My first thought, and when I first did this, was to say, okay, so when the input value is 5, the output value is 3. When the input value for function f is 7, the output value is 3. But I believe that this is a more straightforward way of describing the function f will have an output value of 3 when x is 5 and also when x is 7. Let's look right now at part B. So part B, there's two parts. Find all the zeros with decimal approximation and indicate if there's no such. So above the word zeros on your paper, can you write x-intercepts? And then right here above this part, write round to the thousands. Okay, we're going to do part B first. And so again, if you are with me, those in class have asked to take out their sample books so we can get used to writing in these blue books. And so that's what I'm going to jump over to right now. And I want to demonstrate how we can do this. So whenever we find the x-intercepts, just so you guys are aware, when we find the x-intercepts, we want to know when is the y value equal to 0. So technically, here's how we do it. They're talking about function g. So I want to know for function g, when is the output 0? That's the x-intercepts. So the function is equal to 0 when, and I'm writing this in the same format I just did for the second part of A. Now I'm going to grab this calculator and I'm going to choose to reset it, and then I'm going to go up to y equals. I'm going to come back and I'm going to plug in function g, and as you saw in part A, I erased and I made a little mistake, so I'm going to go slowly through this. And I'm going to recheck my work just to make sure that this problem, I feel confident I can get these points. Okay, I've got it down. Let's graph it here. I know I'm going to have up to 3 roots. That means how many times over the, okay, it crosses 1, 2, 3. Oh, I can see exactly. So there's different ways in which we can go about getting this answer. Really, it's up to you. I want to find the zeros here. So I'm going to go slightly one way, slightly below, slightly above, and then approximation. Now, remember, I want to round to the nearest thousands. So I'm going to come over here and say, okay, the function g is equal to 0, which means we have an x-intercept, or 0, when x is approximately negative 0.362. Okay, let me do the next one. Second trace 0, left bound, right bound, and center. Okay, I have another one here. When x is approximately 0.398. And then my last one, second trace 0. Another way to do this is you can just do an interval. We know it's in between 2 to 8, for instance. And there we go. And when x is approximately 4.048. I'm going to go to part 2 of number 1. So part 2 says, determine the end behavior. Now this is key. On your paper, please write this to underline this. We do not want to give additional information. We only want to precisely answer what they're asking us to do. So we want to express it in mathematical limit notation. So we want to know as the behavior of the function g as x decreases without bound. What the heck does that mean? Okay, so it's very specific about how we write this. So here in part B, we're going to write this down. We want to know as x goes to the far left without bound. So it decreases without bound. This is the function g. And now we want to say what's happening. And one of three things is happening. Your function is headed up without bound, it's headed down without bound, or it's getting closer and closer maybe to a slant asymptote or to a particular value. We can see that as we go to the left, without bound, that our function is headed down, and we represent that with a negative infinity. We got a few minutes left in class, and I don't want to keep you late. For those that are not with me live, a student just said, hey, could I also write down the limit as x increases without bounds? So this person put the limit as x goes to positive infinity, and then it goes to positive infinity. I believe that you would get that counted wrong for precalculus, because precalculus really wants you to only answer the question that's being posed to you. Let's go into part C right now, and I'm going to speed things up. Determine if an inverse function can be constructed. Underline these words. Based on the domain. So we want to use these words when we answer. We want to answer, can an inverse function for f be constructed for all values of the domain? That's what we want to be able to answer. And this is going to be a yes or no. And then, by the way, part 2 of C is like, hey, well, tell me why. So I'm dropping down here. By raising hands in class, how many of you thumbs up or thumbs down are like, I don't even know how to answer that. Thumbs up, thumbs down. Probably pretty common for there to be a thumbs down. Okay, you ready? So on your paper, please write this down on this actual paper here, not in here. You can test if an inverse function can be constructed on a domain by doing a horizontal line test. A vertical line test tells you if something's a function. A horizontal line test tells you if you can create an inverse function based on the given domain. So watch this. I start doing here. Watch. So this passes right here. Right? This passes, but here's where I have trouble. Look at this right here. Well, as long as I find one spot where there's trouble, it can't work. Does everybody see when I take and create a horizontal line of y equals 1? Do you see how I intersect at 2 places? That means that no. And now we want to write this in words that really match up with what I'm given. So I'm going to write no. An inverse function of f cannot be constructed for all values in the domain of f. And you're like, Miss Bradley, is it really necessary for you to write all this? And it is. And here's the reason why. If I went back and I restricted the domain, if I restricted the domain like just from 0 to 1, you'd be like, hey, yeah, I can do that. Or I restricted the domain between 1 and 3, yeah, that I can create an inverse function. If I restrict the domain, I can. But if I'm specific, no. It wants us to know on what we're looking at. So from 0 to 9, don't leave. From 0 to 9, are we able to create an inverse function? And the answer is no. Now down here, please do not leave. Why is it that we cannot? And the reason why is we see that it does not pass the horizontal line test over the entire domain. The function f does not pass the horizontal line test over the entire domain. And an example of this, you can say an example of this is at 5, I have an output of 3. And at 7, I have an output of 3. And I can see here that we do not have a unique, this is key, every output does not match onto a unique input. Don't leave please, every output does not match to a unique, please stay out, to a unique input. It does not pass the horizontal line test. I gave an example, and then I said every output does not match to a unique input.